Hello everyone, welcome to Concepts in Chemistry YouTube channel. So today in this video we will be discussing a very important question from electrochemistry, and that will be the chemistry concept booster question number 32. So let's start without delay. So chemistry concept booster question number 32 from electrochemistry. So cell, electrochemical cell is given. So the question is, now we have to consider the above cell given. The EMF of the above cell with transport at 298 K is this volt. The corresponding cell without transport has an EMF of 0.016 volt. The value of transport number of chloride ion and the liquid junction potential respectively are. So a cell is given. So I think you all know about the cell with transport, without transport. So this is a half cell and this left side is another half cell. So this 3 dot shows that this cell is with transport. If instead of these 3 dots, if there is double vertical line, then we can say that cell is without transport. So without transport means we are using some inert electrolyte to eliminate the liquid junction potential. But in this case, we have to consider the liquid junction potential. That's why we have to find the value of liquid junction potential in these questions. This 3 dot means the cell is without with transport, not without transport. So the cell is given. A cell is the electrolyte. So this is a half cell, right half cell. This is left half cell. The activity, mean ionic activity of HCl of this half cell is 0.09 and that is 0.17. This much data are given. Now we have to find the transport number of chloride ion and the liquid junction potential. So let's discuss the answer with details. So before discussing the main answer, so we all know, I think many of you know already, that electrochemical cell we can there are two types of electrochemical cell. We can write like this: one is chemical cell and the other is concentration cell. So chemical cell is of two types. One is without transport and the other one is with transport. So that without transport and with transport, there is a detailed discussion, details calculations for the for the cell potential, to establish the cell potential of this this cell like without transport or with transport. But in these questions we have to remember, we have to keep in mind some formulas, some general formulas. But this slide is just for general information that electrochemical cell of two types, chemical cell and concentration cell. So chemical cell is again of two types, without transport and with transport. And concentration cell is, one is electrode concentrations and another is in electrolyte concentrations. So electrode concentration cell is always without transport, and if we consider the electrolyte concentrations belonging to this concentration cell, this electrolyte concentration is of two types, without transport and with transport. So this is just for general information. If we want to discuss the details about without transport, with transport, so it will take lots of time. So we will upload a particular video, a special video for this transport, without transport, with transport, and to how to calculate the cell potential for that kind of cell. So now for these questions we have to consider the concentration cells of the category of electrolyte concentrations. So see, in the cell, this is concentration cells, and because so we know already that electrochemical cell consists of two half cells. We all know that if the electrode of the half cells, are dipped in a same electrolyte, same electrolyte, either it is HCl or KCl or NaCl, if the two electrode of the two half cells are dipped in a same electrolyte, then there is no liquid junction potential, and such kind of cells are known as cell without transport. If two electrode of the two half cells in a electrochemical cells dipped in a same electrolyte, then there is no liquid junction potential, and that's why that kind of cell are known as cell without transport. And if the electrolytes of the two half cells, if the electrolyte of the two half cells, this is on half cells, this is on half cells, if the electrolyte, in this case HCl, if the electrolytes of the two half cells are different, means either it's on HCl, on KCl, or in another case they are same, or they are same but at different concentration. See, in this case the two half cells, the electrolyte is same but they are in different concentration, their mean ionic activity is different. So then on bringing them close contact, if we bring these two half cells close contact, then there is migration of ions from on half cells to another via these liquid junctions, and due to this migration of ions, there is generation of a potential across these liquid junctions, and that potential is known as liquid junction potential. And this type of cells where migration take place due to concentration difference of electrolyte, and this type of cells are called cells with transport. So yeah, we will be discuss in our upcoming video, we will discuss details about cells without transport, cells with transport, and we will see there that how do we establish the equations or expressions for cell EMF for each case. So now for these questions, I already mentioned that we are considering that these concentration cells, and that electrolyte concentrations, not electrode concentration always without transport, electrolyte concentrations, and from this category we are considering now the with transport, this with transport, electrolyte concentration cells with transport. So yeah, see again this is the cell given. We can use anything. Normally in major questions HCl, in major cases we usually use HCl, but you can use unipositive cation like KCl, NaCl, LiCl, anyone. So this is cell. For this cell, this is a expression of cell with transport, that's why this 3 dot is there. So the cell EMF of the above cell with transport is given. Now if we remove this 3 dot by double vertical line, means that become a cell without transport. So in that case we are using inert electrolyte to remove the liquid junction potential, and in that case this is the expression of we are showing here, expression of cell with transports. Now if we remove this double 3 dot line and put double vertical line, means we are using inert electrolyte to eliminate the liquid junction potential, and also yeah, they consider also the cell without transport, and also the cell EMF value is given for without transport. Now with transport the cell EMF is 0.028 volt. For without transport, same cell without transport, they measure the EMF and they mention as 0.016 volt. Now we have to find the transport number of chloride ion and the liquid junction potential respectively are. So for to calculate liquid junction potential, we have to calculate the EMF first, assuming with transport, and again we have to put some inert electrolyte to eliminate the liquid junction potential. And if once we get the two cell EMF, first one is cell with transport, then without transport, then we can calculate the liquid junction potential. Otherwise calculation of liquid junction potential will be very tough, only considering one cell, that is with transport or without transport. We have to measure both the EMF by considering with transport and without transport. So let's see the answer and discuss some details. So this is the cell given. I am again telling you that we will discuss in our upcoming videos, particularly or especially these portions, cells without transport, cell with transport, and how to calculate the EMF value of those cells. We will see later. Now for these questions, please keep in mind some formula, and it will be applicable for all unipositive cation like H plus, K plus. Chloride ion is common. Normally we use chloride ion, HCl, KCl, NaCl, but in maximum case people use HCl for this type of calculation, cell EMF. So this is the cell given. This is a cell, concentration cells, electrolyte concentration cell with transport. So yeah, the activity of A plus minus means left half cell is given 0.017. I wrote here A plus minus 1 means for left half cell it is 1 I mentioned, and for right half cell it is A plus minus 2. Activity of HCl in right half cell is 0.09091. If the condition is satisfied, A plus minus 1 greater than A plus minus 2, if these all expressions will only be valued, this all expression I wrote here only valued when the condition is maintained. What condition? A plus minus greater than A plus minus 2, A plus minus 1 greater than A plus minus 2. See here, it is 0.017, this is 0.009. So obviously in this case A plus minus 1 greater than A plus minus 2. Now if that is possible, A plus minus 1 means that right half cell activity of the electrolyte in left half cell is greater than the activity, mean ionic activity of electrolyte in right half cell. So if this is A plus minus 1 greater than A plus minus 2, then we can write this. Please keep in mind, this is always true, always valid. If the A plus minus 1 greater than A plus minus 2, then we can write cell EMF with transport for this kind of cell where unipositive cation and uni-negative anion is used as electrolyte. Cell with transport I mentioned here like WT, EMF E with transport equal to, we can write TH plus. So in H plus, if we use KCl, NaCl, LiCl, then it will be Li plus, Na plus, K plus. If since we are using here HCl, that's why it will be TH plus, means transport number of H plus dot RT by F ln upon A plus minus 1 whole square, A plus minus 2 whole square. This is the expressions. If this kind of cell with transport is given, then the cell EMF with transport we can write EWT, means cell EMF with transport, TH plus transport number of cation of the electrolyte, RT by F ln A plus minus 1 whole square upon A plus minus 2 whole square. So this is the mean ionic activity coefficient of the electrolyte. So yeah, and again if we want to write the cell EMF without transport, then we can write E without transport. So EWOT means without transport. We can write RT upon F ln A plus minus 1 upon A plus minus 2. So please note down these two expressions for cell for this kind of cell, electrolyte concentration cells. This is the expression of cell EMF of with transport. This is the expression of cell EMF without transport. So these are the expression of with transport and without transport. Now if we divide cell EMF without transport by if we want to calculate these expressions, E without transport divided by E without transport. E with transport means cell EMF with transport divided by cell EMF without transport. Then from this expression we can write, so yeah, TH plus this equation. So we can write this ln A plus minus inside the bracket and whole square. Then this 2 become this power become just before the ln we can write, if 2 ln A plus minus 1 upon A plus minus 2, we can write ln A plus minus 1 upon A plus minus 2 whole square. This is just mathematical calculation for ln, properties of ln. So now we can write this this 2 will become before this ln. Now we can write 2th plus RT by F cancel out, ln A plus minus 1 upon A plus minus 2, this whole term will cancel out, this 2 will become this 2 will come just in front of ln. Now only 2th plus will be there. So this is also, you please keep it in mind or note down. Now E with transport, cell EMF with transport for this kind of cell divided by cell EMF without transport equal to 2 times of transport number of cation. In this case H plus is cation, that's why 2th plus. This is, so this one, this is the expression of cell EMF with transport, this is the cell EMF expression of without transport. E with transport upon E without transport, we got 2 transport number of H plus. Now the EMF or potential at liquid junction. So EJ means the liquid junction potential or potential at liquid junction, that is LJP we can write. E LJP means E liquid junction potential. So liquid junction potential we can write simply E with transport minus E without transport. So cell EMF without transport minus cell EMF without transport, we will get liquid junction potential. The EMF at liquid junction, that is liquid junction potential, that is E with transport minus E without transport. If we put the values from previous, then with transport TH plus RT by F ln whole square. If we put just normal mathematical calculation same, then if we common RT by F ln A plus 1 upon A plus 2, then we will get 2T H plus minus 1. From here 2T H plus, and from this term 1 will be there. So now 2T H plus minus 1, we can write 1, we can write we all know, I think 99% of you all know that the transport number of cation and plus transport number of anion equal to 1, we all know. T plus T minus transport number of cation and plus transport number of anion, the summation of transport number of cation and transport number of anion of a particular electrolyte will be equal to 1. So that's why we are putting here on, in place of on we are writing here TH plus TCl minus. For HCl, H plus is cation, Cl minus is anion. Now TH plus TCl minus transport number of cation plus transport number of anion is equal to, always is equal to 1. It is universal truth. For a particular electrolyte, transport number of cation and transport number of anion is equal to 1 always. So 2TH plus minus, in place of 1 we are writing here TH plus TCl minus, transport number of cation plus transport number of anion, and that will be the same. Now 2TH plus minus TH plus, so 1TH plus will be there and minus TCl minus will be there. So at last we will get, at last we got expression like this: EJ, that is EMF at liquid junction, or the liquid junction potential is equal to T plus minus T Cl minus. So transport number of cation minus transport number of anion into RT upon F ln activity of electrolyte in left hand cell divided by activity of electrolyte to right hand cell. This is the cell, left hand cell half cell, right hand half cell. This is the activity of right hand half cell, activity of left hand half cell. So A plus minus 1 we consider here this one, left half cell activity, mean anionic activity, and A plus minus 2 right half cell mean anionic activity of the electrolyte. So now we obtain equations or expression like 3-4 expressions we have to keep in mind. E cell EMF with transport, this, keep in mind square is there, square is always there. If we, we will see later in separate video detailed discussions. And E without transport, no square term will be there. Activity term square is there with transport, without transport no square term will be there in the activity term, and in this case TH plus is there, here nothing is there. If we want to see, we will see, obviously we will see later the whole details calculations to obtain this kind of expressions. I just want to mention that there are lot of calculations, so it will take lots of time if we want to show now, but lots of calculation, lots of big calculation is there to obtain this kind of expressions. So please keep in mind, with transport, without transport, if we want to calculate this term E with transport upon E without transport, then we will get 2 transport number of H plus, 2 times transport number of H plus, that is cationic transport number. And from this, if we want to calculate the liquid junction potential expressions, then we will obtain like this. And also, yeah, we obtain the expression like this: T plus minus T minus means transport number of cation minus transport number of anion into RT upon F ln A plus minus 1, A plus minus 2. No square term is there, only this A plus minus 1, A plus minus 2. A plus minus 1 is the mean ionic activity of the electrolyte in the left hand cell, and mean ionic activity of the electrolyte in the right hand cell is A plus minus 2. So these are the some expressions. Now in the questions, they already given that the EMF means E with transport already given 0.028 volt. E without transport they already given in the questions 0.016. Now the we have to find the transport number of anion, that is chloride minus, and the potential at liquid junction means EJ, liquid junction potential. So we all know from these expressions that E with transport divided by E without transport equal to 2 TH plus. So for this, if we want to write T2H plus E with transport upon E without transport, so if we put the value, then we will get 1.75. So now TH plus become 0.087. So we got this 0.087. We got the transport number of H plus means cation 0.0875, and we all know the transport number of cation plus transport number of anion is equal to 1. This is always true. T plus T minus transport number of cation plus transport number of anion is always 1. This is true. So TCl minus become 1 minus TH plus. So 1 minus 0.87 means 0.125. So it's become the transport number of chloride ion or anion. Now we got another one answer. Now the second answer, we have to find the liquid junction potential. So we found here expression of liquid junction potential or ELJP, E liquid junction potential is equal to E with transport minus without transport. Since in the questions this EMF were given, that's why we directly put here without transport E minus without transport, E with transport minus E without transport, that is 0.012 volt. If this with transport or without transport are not given, only some transport number of cation and anion were given and the activity is already given in the cell, then we can also find the liquid junction potential. If this EMF were not given, suppose assume that this EMF with transport or without transport are not given, then they have to mention, they have to give some value like transport number of H plus or transport number of N minus. If they will give only one transport number, then from this calculation T plus T minus equal to 1, we can calculate the other transport number and we will put this value. Activity should be there in the cell, RT by F, we will put the value, then we will get the liquid junction potential. Since in the questions already E with transport and E without transport are given, that's why we no need to use this last equations, just put the value in the first these equations, then we will get the value 0.12. So they asked about the TCl minus. If they will ask about TH plus, then the answer will be 0.875, and we all know that the transport number of H plus is very high compared to sodium plus, Na plus, Cl plus, and OH minus. The transport number of OH minus is very high compared to Cl minus, Br minus, and F minus. So the transport number of Cl minus is 0.125 and TH plus is 0.875, and the liquid junction potential is 0.012 volt. Now see the options. So first transport number of chloride ion and then liquid junction potential respectively. So liquid junction potential should be 0.012. So 0.012 volt. Option B and option A is there. Now transport number of chloride ion in D 0.012 and in D 0.0125. So C, transport number of Cl minus is 0.0125 and the EJ means liquid junction potential is 0.012 volt. So the option is correct option is option A. If they uh, if they have asked about that TH plus means transport number of cation, then the answer will be 0.0875 and 0.012. The liquid junction potential will be same, but if they will ask about the transport number of cation, then we have to put the value 0.875. So in the question they asked about Cl minus transport number of chloride ion, that's why the answer will be 0.125 and the EJ value 0.124. So yeah, the correct option is A. 0.125 is the transport number of chloride ion. Liquid junction potential is 0. So yeah, 0. So this is 0.012 volt. Yeah, see the answer. So on mistake, I think on mistake is there. So during putting the options, so 0.012 volt is that the liquid junction potential, but the transport number of chloride ion is 0.125. So there should be a zero term 0.012. So there should be on 0.012 volt, not 0.12 volt, because we made this options and we made this questions from different kind of source. So just to show you the concept about this concentration cell. So sorry for that mistake, because see 0.012 volt is there, but the transport number of that anion is 0.125, not 0.12 something. So this option is not correct. But in these options, so mistakenly we put the value 0.12 volt. So the option, so the correct value should be 0.012 volt. Then this option will be correct. This is for chloride anion transport number, and this is for the liquid junction potential 0.012 volt. So sorry for that small mistake. Yeah, I hope that you guys understood the concept or the theory behind this kind of questions. Concentration electrolyte, concentration cell, with transport, without transport. We saw some expressions, that is expression of with transport, expression of without transport, that is the cell EMF expressions, expression of without with transport EMF divided by without transport, that is 2 times of cationic transport number. And that the we also see here that the liquid junction potential EMF value of liquid junction potential is transport number, cationic transport number minus anionic transport number into RT upon F ln activity of left hand side electrolyte divided by activity of right hand side electrolyte. Also we can we also saw that the liquid junction potential we can write E cell EMF with transport minus cell EMF without transport. So in detailed calculations we just saw the answer. And yeah, I hope guys this discussion of this kind of questions will be very helpful for all of you. And yeah, stay tuned, stay update. We will upload lots of conceptual questions in our upcoming videos. So thank you for watching. Yeah, that's all for now. Stay safe, stay healthy. Bye.